What's up, Five Keys? I just recorded like 10 minutes worth of video and accidentally deleted it. Mad. It's Friday, January 28th, 2022. And other than my little technical mix up, it's going to be a glorious day. I'm recording these out of order. So if I don't know, if I don't have a beard in the previous one, I do now. Sorry to confuse you. Be quiet, phone. Okay, so today we're going to look at the standard form of the equation. Now let's see if I also deleted the notes I had made because, I didn't. Awesome. Okay, so I'm just going to talk through this real quick and then we're going to get into it. And the good news for you is that I may keep this video a little bit shorter than I normally do. So we went over 2 lessons ago, slope-intercept form, this y equals mx plus b, where m is the slope and b is the y-intercept. That was slope-intercept form. B is where the line crosses over the y-axis, the y-intercept, and m is the rise over the run. It is the rate of, or level of steepness, I should say, of the line itself. The next thing we went over was another form of the line that we can write it in just by moving numbers around, which we called point slope form. Which was y minus y sub 1, where y sub 1 was a y coordinate of any point on the line equals m, our slope, times the quantity of x minus x sub 1, where x was the corresponding point on the line, if that makes sense. For y sub 1. So x sub 1 and y sub 1 are actually a point on the line. And this was very useful when we had a point, and when we knew slope, we could graph it, or we could write the equation if we knew what the slope was and we knew what a point on the line was. Now we're going to move into a new thing called standard form. And again, all we need to do is move some numbers around to come up with these new things. And standard form is ax plus by equals c, where a, b, and c are real numbers. They can be any real number, rational or irrational, but we generally use this when they are integer numbers. Yeah, meaning whole numbers, right? That's generally how we list. That's generally how we use capital A, B, and C when we're talking about the standard form of the line. So you won't usually see 1/2 x plus 2/3 y equals 3 over 2, right? You will generally see 2x plus 3y equals 1, or whatever it's going to be. One thing I want to point out to you is this lowercase b over here and this capital B over here, they're not the same thing. They're not the same thing, okay? This is slope-intercept. This is a coefficient. It really doesn't correspond to anything specifically on our graph, although we can use it to very efficiently calculate certain things, specifically our x and our y intercepts. These guys right here, the point at which the line is going to intercept with the x and the y. Okay, enough about that. Let's stop share. Let me share our assignment and get rolling, okay? So the first question after all the kind of blah, blah, blahs is why would it be easy to find x and y intercepts using this standard form? Ax plus by equals c. I'm not going to give it away entirely because I want you guys to wrestle with it and struggle with it and come up with an answer on your own, and feel free to be wrong. It's fine. I am going to give you a hint though. If here are my axes, right? Here's my y and here's my x. What do I want to do? Yeah, sure. We can do negative slopes. Okay. So here's the y. What is x? What is the value of x at the y-intercept? It's 0. This point is the origin and it's 0, 0. So there's vertical height here, meaning there's an up and down height, but there's no left and right distance, right? So this has some value, but there's no distance left and right. It's 0. So whatever this length is, I'm going to call it R. I don't know why. That point here is 0R. Similarly, for my x-axis, let's maybe call it n because that's what I wrote. For my x-axis, what's the y value? Well, the y value, it doesn't have a value. It's 0. So this is going to be, we'll call it m. M's confusing. Let's call it p 0. So why am I blah, blah, blahing about that? Well, so if I want to calculate my x value, the value of my x-intercept, I should say, what number should I put in for y? Hint, hint, hint. Similarly, if I want to calculate my y-axis, what value should I put in here for x? Hint, hint, hint. Another hint. What is any number times 0? 0. 0 is like a bomb. It destroys everything. Everything goes away, right? So how would that simplify by plugging in zeros for our values for x and y? How would this become a very easy equation to work with? Or form of the equation, I should say. Okay, I kind of maybe gave you a little bit more than I would have liked, but that's okay. Okay, so here's an example. I will let you go off on that on your own. Find the x and y intercepts of the equation below. So if you didn't do that first question, answer that first question. Try. Just put something down because now I really am going to give it away. So find the x-intercepts and the y-intercepts of the equation below. All right. So a few notes here. X-intercept, y is 0. The reasons I just discussed. Y-intercept, x is 0. For the reasons I just discussed. Okay, so how do I find the x-intercept? Y is 0. So I'm going to plug in a 0 for my y. Now I'm going to end up with 5x minus 6 times 0 equals 60. This becomes a 0. 5x is equal to 60. So that I know my x-intercept now is some number times 5. So 5 times my x-intercept will give me 60. How do I solve for that? Well, what would happen if I multiplied both sides by 1/5, the reciprocal of 5? I would get only 1x, which is what I want. And 1/5 times 60, if you want to use a calculator, is 12. So there's my x-intercept. My y-intercept, well, when to find the y-intercept, x is 0. So I'm going to say 5 times 0 is negative 6y equals 60. This goes to 0. I have negative 6y equals 60. And y is equal to negative 10. And this is my y-intercept. Okay, this is the algebraic way of doing that problem. By algebraic, I mean I didn't look at anything graphically. I just plugged in numbers to my equation. So now, how else could you do it? Well, I'm going to pull up Desmos, my handy dandy graphing calculator, and I'm going to not delete this whole screen, but I'm going, oh man. I want to leave up my, oh man, I guess I can't. Oh well, it's not that important. There's the next question, okay? Boom, 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 boom. What is my y-intercept? Okay, so this is 1 and this is 2. So these are 1, 2, 3, 4, 5. This is right in between the 1 and the 2. So my y-intercept here may be, oh, it just told me 0, 1.5. So 1.5 is my y-intercept. What's my x-intercept? 4, 0. Okay, notice what is the x-coordinate of the y-intercept? It's 0. What is my y-coordinate of my x-intercept? It's 0, right? Okay. So this is what's happening visually when a problem asks for the x and the y-intercept. This is what it's looking for. So the convenience of the standard form is we can do what we did a moment ago, and we can do it algebraically, relatively simply. It's also an easy sentence to look at. Graph the line x minus 2y equals -2. All right, so they're going to do that. You try. Graph the line 2x plus 5y equals 20. Okay, so I'm going to find my intercepts, right? So my y-intercept, no, my x is 0, which would give me 2 times 0 plus 5y equals 20. This is 5y equals 20 because any number times 0 is 0. So it just goes away. Y is equal to 4 because 5 times 4 is 20. All right. So now I just figured out my y-intercept. Awesome. So the y-intercept, the point is going to be 0, 4. Let's, can I do that? Will it go up? No, probably won't. Okay, let's just do it over here. X-intercept, y is 0. This would give me 2x plus 5 times 0 equals 20. 2x, let's go lowercase for consistency, equals 20. X is equal to 10. So my x-intercept point is 10, 0. Boom. Okay, but that's not what the question is asking for. The question is asking us to graph it. I just made those notes because I wanted to. So here's a quick, here's the quick and dirty version of it. Y-intercept 0, 4. I'm going to call my 4 here. X-intercept 10, 0. If this is about the distance of 4, I'm going to double it and add a little bit. This is about 0, 10, 0. And then I'm going to connect these 2 dots. That line keeps going that way. That line keeps going that way. The really fast way of doing this is this. Copy. Hello, Desmos. Paste. I got a cool line. I'm going to clear my drawing. Up, up, up. I'm going to reframe this a little bit so I get a good image of it. There's my 4. There's my 10. Cool. My rough sketch was right. Share my graph. I'm going to export the image. Fine. I'm going to download PNG. I don't even know what that is. Doesn't even matter. I'm going to take this and I'm going to drop it right into my Google Doc and look. Done. Less than 10 seconds to do that problem. Okay, moving on. Here's a special case of lines. They are of the form y equals k or x equals k, where k is a real number. The first line is horizontal. What's horizontal? Well, it's like if you're looking at the horizon, it's left to right. It's flat. The second, vertical, if someone were to say a vertical drop, straight up and down. Check it out. So the y equals k is a horizontal, x equals k is the vertical. Here is a x is equal to 3. It's a little fuzzy on my screen, so I'm sure it's super fuzzy on yours. But if you want to notice, this is a vertical line in the standard form, 1x plus 0y equals 3. And y is equal to 3 in the standard form that would look like 0x plus 1y equals 3. And here's our horizontal line. It's important to know how to transform from one form of a linear equation to another. Okay, I think they might be moving on. One thing I want to point out, this is a function. Y equals 3 is a linear function. X equals 3 is linear, it's a straight line, but it is not a function. It does not pass the vertical line test. It is itself a vertical line. That's important to know. Okay, the slope here is undefined. The slope here is 0. It's important to change from one form of a linear equation to another. So here they have a line. It's in slope intercept form, and they're going to change it into standard form. This is mx plus lowercase b, which is different than uppercase b. So let's see the math that they do. Okay, well, the first thing it looks like they did was they added positive 37x to both sides to get rid of the x on this side and to bring it over here. And then they had this fraction. Technically, you are in standard form with 3 over 7x plus 1y equals 5. A, B, C, these guys here, just need to be real numbers. The technical definition of the standard form says nothing about them having to be integers or whole numbers, in other words. But it is best to express them as whole numbers. It just makes your life easier. So they're going to multiply both sides by the lowest common denominator, which is 7. And by doing so, it's simplified out to 3x plus 7y equals 35. Let's do the U try. So try it on your own. See if you got it. Okay. This is wild though. So they're recommending that the first thing you do is change it to slope intercept form. Change it to slope intercept form. So let's do that. Let's change it to slope intercept form. Because I don't know how I'm going to do it, but I know I need to get it into that form, into this form, ax plus by equals c, where b, y, and c are actually numbers, real numbers, and preferably whole numbers, and x and y are semi-variables. So I guess my question to you really quick is what form is it currently in? This is point slope form, if you recognized it. 1/3 is our slope, +2 and a negative, and our point is -6, +2. Remember, in point slope form, the signs shift. They switch. Okay, so I'm going to change it to slope intercept form, which is y is equal to mx plus lowercase b, which does not involve a parentheses here. So I'm going to distribute the 1/3 1/3 times 6 is 2, and it's negative, so this is going to be a -2. And then the last thing I have to do to get it into the form of y equals mx plus b is I'm going to add 2 to both sides. I'm going to work vertically to save a little time and space. I'm doing this to isolate my y because I know in oh my goodness, in slope intercept form, I've solved for y. And oh look, -2 plus 2 is also 0. So the y-intercept of this graph is 0. I also want to make a note that the x-intercept on this graph is also 0. And we have what's called a direct variation equation. And we can refer to the slope now as the constant of variation, right? This line goes through the origin at 0, 0. How is this going to help us actually solve the problem? I don't know. I do know, though, that I want it to look like this. And in order for it to look like this, I need both my y and my x on this at the same side, okay? So I'm going to add 1/3 x to both sides of the equation. Actually, I will work horizontally in this case, okay? Plus 1/3 x. That x is meant to be in the numerator. I'm sorry if I'm not writing that clearly. I'll try to do it better on the left side. 1/3 x plus y. Okay, so what does that bring me to? 1/3 x plus y is equal to 0. I have met the parameters for the standard form of the equation at this point. I can be done, but I'm not going to be. I'm going to do one more thing to make it a little bit more pretty. And I'm going to multiply by my least common denominator to get rid of that fraction, okay? So I'm going to multiply the whole side of the equation by 3. I'm not allowed to just multiply one term. I have to multiply both terms. And then I'm going to multiply my right side of the equation by 3 as well to keep things balanced. Okay, I'm choosing 3 because it's the reciprocal of 1/3 and it's the least common denominator as well. 3 times 1/3 is 1, so I'm left with 1x. 1, because I assume there to be a 1 if I don't see a coefficient next to my variable, is 3. Y is equal to 0. Boom, I'm done. Oh, look, this is interesting. I bet you can make a solid statement that whenever you have a direct variation equation, I'm just going to erase this to remind us what this is. That's an equation that when in slope intercept form, there is no b, right? The y-intercept is 0. That the standard form is going to have a c of 0. I bet that's true. Maybe it is, maybe it isn't, I don't know. But I don't want to do the formal proof now, but it's true. Okay, now that you've seen all 3 important types of linear equations, here's a recap. Slope intercept mx plus b, point slope y minus y sub 1 equals, it looks like that's a minus sign, but that's meant to be an equal sign, m times x minus x sub 1. And then standard form ax plus by is equal to c. These 3 specific equations all represent the same line. They just look differently, and there's different reasons we might use this. This is the dog runs. This is the dog is running. This is the dog does run. I don't know. The dog does run. It's kind of not the best use of the English language, but I can't think of a third way of saying the dog runs. So there it is. Okay. Hey, we're done. Let's look at the quiz. And then we will really be done. Let me toss this so I don't clutter my my life. So while I'm pulling this up, you should pull it up also and take the quiz and pause the video while you do, because that's how we roll, right? You're doing the quiz, and then once you have a good sense of what it's all about, you will replay the video and see how you did. Or you can check my work, because maybe I'm the guy who messed up. What are the x and y intercepts of the equation negative 3x plus 5y equals 15? We have multiple ways of doing this. We can go to Mathway, or Desmos. I think it might be the more effective way of doing it. Or we could do it algebraically, which is what I'm going to do here. So I know that to get my x-intercept, I'm going to set my y equal to 0. So that's negative 3x plus 5 times 0 equals 15. This is negative 3x equals 15. What do I need to multiply negative 3 by to get positive 15? I need to multiply a negative 3 by negative 15. So my x-intercept, that's not true, negative 5. My x-intercept is negative 5. For my y-intercept, x is 0. So let's do the math here. I have negative 3 times 0 plus 5. Y is 15. I have 5. Y is 15. Oh, what am I saying? 5y is 15. What do I need to multiply 5 by to get to 15? Well, if y was 3, that would get me there. So there are my x-intercepts, negative 5, and then my y-intercept is positive 3. What is the graph of 5x minus 2y equals 20? Again, we can do this a couple of different ways. We could attack, let's do it the algebraic way, okay? You could absolutely go to Desmos, type this in, and be done. I'm okay with that. You can even copy and paste. That's what Desmos is for. You might as well take advantage of it. But let's do it the way it's intended, okay? So for my x-intercept, 5x, I'm going to plug in a 0 here. So negative 2 times 0 is 0. So I know 5x equals 20. What do I need to multiply 5 by to get to 20? X is 4. So I have a point at 4, 0. Let's look at the y-intercept. I'm going to set my x equal to 0. 5 times 0 is 0. I have a negative 2y equals 20. What do I need to multiply negative 2y to get to 20? Well, negative 10. Meaning that I have a point at 0 and negative 10. So what does my graph look like? Well, not as bad to do this as you might think. I should draw on this a little differently though. Yeah, okay. So notice the way I'm going to draw this. I'm going to draw my origin way up here. Why do I do that? Well, because I know what my points are. You'll see what I mean in a second. So if I'm going to do this point first. If my negative 10 is here, well, it's about this distance, half of it, a little less. Boom. This is 4, 0. This is 0, negative 10. Doesn't have to be exact because I'm just sketching. I missed. I'm working on a mouse, forgive me. Desmos will give you an exact image of this, but this is what the line is, okay? The dog runs. This is a picture of the dog running. It is not the actual dog running. I hope that makes sense, right? This is modeling the dog running, all right? Maybe it's modeling where it is in space and X is time, right? Okay. Clear all drawings. I think, what? We only have one more to do. That's incredible. So what is y equals -2/9x + 3 in standard form? Make sure the x and y coefficients are integers. Okay, so the question is very specifically asking us to make sure a, b, and c are integers. That's what they mean by the coefficients. A, b, and c. I'm sorry, c is not a coefficient. C is a constant. A and b, because they're next to the integers. Because, oh my goodness. A and b, because they're next to the variables, are coefficients. C is a constant because it's not. All right. So what's the first thing I want to do to this guy here? Let's move my x over, because I know that that's the form, right? A x plus by equals c. So at this point, I have 2/9 times x plus 1y equals 3. I am in standard form now, but I have not satisfied the problem, because it's very specifically asking me for this number and this number to be coefficients. The one to be integers. These are my coefficients. I'm going to put a 1 here. The 2 and the 9 and the 1 are coefficients. And they're asking me very specifically to be integers. An integer is a whole number. The difference between a whole number and an integer is that integers include the negatives. So we're allowed to be negative. We just can't have a fraction. So I'm going to multiply by the least common denominator, which is 9. Notice that I'm not multiplying by the reciprocal, which would be 9/2, because I don't want this to be 1 necessarily. I want it just to be an integer. I just need to get rid of the denominator. And then whatever I multiply my left by, I have to multiply my right. Okay, so what's 9 times 2/9? Well, the 9s are going to go to 1. That's by design, but I'm still left with the 2. What's 1 times 9? 1 times any number is the other number. So that's 9y. And then 3 times 9 is 27. And that's it. You're done. So let me stop share. That was a quick one, or quicker than they normally are. Thank you very much for your good work. I think we're getting into some really wild stuff on the next couple, but cool, man. This is where math gets fun, I think. And thank you for your good work. Okay, I'm done. Stop recording. Bye.